When you're at the beach in the middle of summer, you've probably noticed this. The sand gets hot. You have to jump around for a while, or find a patch of grass, or even jump into the ocean to cool off. And you certainly wouldn't want to touch the hood of a car. Ow! But wait, the sun's rays radiate the same amount of heat onto everything, but substances don't all heat up in the same way. So what's going on here? Well, I'm George, I'm here in sunny south of France, and I'm about to tell you. The fact is, all substances on Earth heat up differently. Metals, for instance, require only a small amount of heat to change their temperature. Putting that same amount of heat into water would not increase the water's temperature by nearly as much. Scientists have studied this phenomenon, and they've actually calculated a number for each substance called its specific heat. Specific heat is, put simply, the amount of energy it would take to raise the temperature of 1 gram of a substance by 1 degree Celsius. While that might sound like a mouthful, let's break it down to make it easier to understand. If I were to take an equal mass of steel and water, both at room temperature, and put them in direct sunlight, they're now being exposed to heat energy, and should therefore begin increasing in temperature. But when exposed to the same constant source of energy, it takes longer for the water to heat up. This means that it takes more energy to increase the temperature of the water. As such, we can say that the water has a higher specific heat than the metal. You can think of specific heat as a substance's ability to hold and trap energy. By looking at a table, we can compare the specific heats of different substances to see how they interact with heat energy differently. If we look at steel, for example, we can see that it has a specific heat of 0.47 joules per gram degrees Celsius. This is a relatively low specific heat, which means that it doesn't take a lot of energy input to increase the temperature of steel. Liquid water, on the other hand, has a specific heat that's almost 10 times that of steel. This means that it would take almost 10 times the heat energy to increase the temperature of the same mass of water by the same number of degrees.
Ta-da!
Water tends to stay cooler than other substances because it takes a lot of energy to increase its temperature. Come on. However, when we do encounter water with a higher temperature, it means that it's holding more energy than another substance of the same temperature. Consider this. The hood of a metal car may heat up a lot if it's left out in the sun. Ow! But shortly after you put that car back into a garage, it begins to cool down. A tub full of hot water, on the other hand, will retain its temperature throughout the duration of a bath. This is because all substances that are hotter than room temperature will naturally begin to shed their heat energy. Because water has far more heat energy, it takes a longer time for it to cool back down. In this graphic, I have two substances, water and steel, both at a very high temperature. As time goes on, we'll see that both substances naturally lose some heat to the outside world. However, after losing only a small amount of heat, the steel's temperature goes down. Water, on the other hand, has a high specific heat, which means that it's holding a lot of heat energy. So even though it loses the same amount of heat that the steel does, it does not decrease in temperature. Specific heat is a characteristic property of matter, which means that it remains true no matter how much of the substance that you have. At the grandest scale, this is why oceans and large bodies of water have a moderating influence on climate and weather. In the summertime, oceans stay cooler than the land because it takes far more of the sun's energy to heat them up. The opposite is true in the winter, when the land cools down quickly and it takes the ocean far more time to lose the energy it has trapped. Now you know what there is to know about specific heat, and if anyone asks you where you learned, you can just say, George told me.